Hello dear friends. Today we will look at the first problem in the topic Basic Concepts and Laws of Electrical Circuits. We solve problems like this using Kirchhoff's laws and relationships between voltage and current in ideal circuit elements. In this problem, we have a series circuit with a resistor and an inductor. We know the current and it changes according to the law 2 times T squared. Here 2 isn't just a number, it's a coefficient with units tied to current and time. By multiplying time squared by this number, we get current in amperes. Our goal is to find the voltage across the terminals of these circuits. To do this, we use Kirchhoff's second law. It says that the algebraic sum of voltages in a mesh equals 0. We will go around this mesh clockwise. The voltage across the resistor is in the same direction as the current and the direction of the loop, so we take it as positive. The inductor is also a passive element. The voltage across the inductor is also the same direction as the current and we take it as positive too. But the voltage across the terminals of this circuit, which we need to find, is in the opposite direction of the mesh. So, we take it with a minus sign in our equation. When we solve the equation, we see that the voltage across the terminals equals the sum of the voltage across the resistor and across the inductor. So our task is to find these two voltages and add them together. To find these voltages, we use the relationships between voltage and current for ideal circuit elements. We covered this in the lecture number 3. Here you see a slide from that lecture. The table on that slide shows the relationships between the current and voltages of the passive elements. I hope you remember these relationships. We will use them to solve this problem. First, we find the voltage across the resistor using this formula. Then, we find the voltage across the inductor using this formula. For the resistor, voltage equals resistance times current. So, we multiply 10 ohms by 2 and by T squared, giving us 20T squared. This is how the voltage across the resistors change over time. For the inductor, the voltage is found by taking the derivative of the current and multiplying it by the inductance. We have an inductance of 2.5 henries. The derivative of 2 times T squared is 4T. Multiplying it by 2.5 gives us 10t. Now we simply add 20t squared plus 10t. That is the voltage across the terminals of the circuit. At this point, we have solved our problem. Now let's visualize it using Microsoft Excel. On the graph, the red curve shows the current over time, which is a quadratic parabola. The blue curve shows the voltage we found. To understand this topic fully, make sure to watch the related lectures. The links are in the description below. Thank you for watching, and I wish you all the best.